Hi and welcome in the 6th episode of Advanced Python. Today we will be covering sets. In Python, there are four main types of containers or types of different lists which can be used to store data. The first one being a simple list which can be defined using square brackets. The second one being a tuple, which is defined using regular brackets. A dictionary, which is defined using curly brackets, as well as defining specific keys through which you can access every piece of information inside of that dictionary. And there is also a fourth type, which is the type we will be covering today, and those are sets. There are actually two ways of defining a set. The first one simply using curly brackets and not giving identification keys like in the case of dictionaries. And the second method is using the set function to convert something else into a set. So as you can imagine, sets are probably slightly different than all the other options, but what exactly makes them different? First off, sets are actually unordered, unindexed lists, meaning that any values inside of sets don't actually have indexes and they don't have any specific order. So you can't really retrieve a specific value without going through the whole set at once. However, that's not really what sets are for. Sets are used for something slightly different. They're actually used for things such as finding differences in between the sets, merging the sets together, finding values which repeat across two different sets, or a couple of other things. Another important fact about sets is that they actually cannot contain two exactly the same values inside of a single set. You cannot have two exact same pieces of data inside of a set like you could inside of a list or a tuple. So if I would actually take my set now and try to give it value of 1 multiple times, like so, if I actually print my set, you can see that even though I added 1 3 times, it actually only appears a single time inside of our set. Another useful thing which sets can do is actually they can scan through an entire string of text and then pick out each word only once because they cannot have repeating values. Meaning we could define a string with a bunch of different sentences and then we could slice it up, let's say separating things by spaces, and our set would only have each unique word once, and then you could perform operations on those words. So let's try and do that with our set 2 by defining string first, and let's make up some sentences with repeating words. And then after we defined our string, I'm going to use a function called split so that our sentence gets split in slices in the place of spaces. So if we actually redefine our print statement to show us our second set and we run the file again, you can see that our set only consists of each word once. It doesn't have any repeating values. However, it is also important to notice that if there is even a tiny change in a word, for example, a capital letter instead of a lowercase letter, the word can be duplicated because Python doesn't see that as the same piece of information anymore. So as you can see, our set was created using the words are, winter, the with small t, as well as the with capital T, Christmas, presents, coming with a dot, as well as coming with a comma, and is. You can also see now that there isn't really any particular order in which those words have been placed here. They have been just randomly assigned to the set because they don't actually have an order, they don't have any indexes. And it is actually also impossible to use square brackets and attempt to call an index from the set, because if you try to do that, your Python's just going to crash. For this next example, I have prepared two different sets, which aren't actually fully different. They actually have a few repeating values, such as bread, pasta, or ketchup, but they also have some of their own unique values, milk, mustard, and pickles being for the first set, and ginger, cucumbers, and tomatoes being the unique values of our second set. Now I'm going to show you a couple of operations which you can do containing two different sets. The first one is actually the intersection command, which can be specified by mySet.intersection, and then in brackets I would put my second set, so my set 2. And what this command does is it actually takes both of your sets, it checks them against each other, and it finds the values which appear in both sets at once. So if I would print it using the print statement and run our program, you can see that the only values we get is ketchup, pasta, and bread, because those are the only things which are actually exactly the same between our two sets. So the intersection function is actually used to find things which are the same in two different sets. The second function is actually difference, and the difference command will take the first list, then check it against the second list, and only return the values which are on the first list, so our set first. It will check it against the second set, my set 2, and it will only give you back those values which appear in our first set but don't appear in our second set. So if we run it, you can see that it only prints mustard, pickles, and milk, because those are the values inside of our first set which don't appear in the second one. If you would like to reverse it, you can simply call your second set dot difference and then in brackets put the name of your first set. And if you would run that, you would get ginger, cucumbers, and tomatoes, because those are the things inside of the second list which don't appear in the first one. If you would actually to find the difference in between the two sets which spans across both of them, so we would like to find the values from set 1 which are not present in set 2, and also at the same time values from set 2 which are not present in set 1, there's also a command which can do exactly that. And that command is called symmetric difference. It's used exactly just like the previous ones, my set dot symmetric difference and in brackets my set 2, and if we run it now, you can see that it prints out all of the 6 specific values which appear in set 1, don't appear in set 2, as well as appear in set 2 but don't appear in set 1. So basically the differential values which are not the same in both sets. Another useful thing you can do with sets is actually my set dot union, which you might maybe guess takes both of the sets and combines them together, creating a new set from all of those collected values. So if we run it again, you can see that all of the unique values which appear in both lists appear over here. However, like I mentioned previously, no values can actually be repeated in a set, so that's why we don't have repeating words for bread, pasta, and ketchup, even though they appear in both lists. If you want to add a specific value to a set, you can do so by providing mySet.add and then in brackets inputting your piece of information which you want added to your set. So for example, we could say bananas, and if we run it again, you can see that we get our entire set plus the word bananas merged somewhere into the set. There's also a way to remove values from a set by using dot discard and then giving it a value which you want to remove. So let's say we want to remove bread. If I run it, you can see that we get our set again. However, it doesn't anymore contain bread. And the last command I actually wanted to talk about is mySet.pop, which actually takes the leftmost value from the set and removes it from the set, just like the discard command. However, into here you cannot actually enter which piece of data you want to remove. It will simply remove the leftmost one. We can see it easier by doing it a couple of times in a row. So let's print our set first, then let's pop a value, let's print the set again, and let's repeat that a couple of times. So if we run it now, at first we get all of our values from our set, then the leftmost value is being removed, so mustard, then the leftmost value again, ketchup is removed, and so on and so on. It's always the leftmost value. However, you have to be careful with that because, like I mentioned previously, sets are actually unordered. So even though our set over here says mustard, ketchup, pasta, milk, pickles, and bread, while we were setting it, it was in a completely different order. And if we run it again, you can see that the order changes again. So if you're doing it this way, you really have to know what you're doing, because you can't remove specific values like you would with the discard command. And that would be it for today. See ya!